Hey everybody, Monty, Geometry, Week 9, Friday, November 13th, and we're going to be putting away the circles and going back to four-sided objects, quadrilaterals, okay? So, vocabulary, you should be familiar with all of the words on the screen right now because that's where we started school. What makes a square a square? But now we're going to build upon that, okay? How are we going to build upon it? We're going to analyze the diagonals, the angles created in the corners, okay? The vertices. What can we say about those angles of each of these shapes? And then when we create the diagonals, what can we learn about the opposite angles? What corresponds to what? Okay, so a key word will be the word corresponding. But for today, I want you to not stress the volume. Just 20 minutes outside of class. We're not going to get all these shapes done in 20 minutes. So pick 2 or 3 that you're comfortable with so that we can focus on the opposite angles. When we draw diagonals, what do we notice? And conjectures. What predictions can we make? All right, so before we get started, focus on the angles inside the object. Are the opposite angles truly equal? Opposite means corner to corner. A square. A square has 360 degrees, 90, 90, 90, 90. So does a rectangle. So in the back of your minds, is a square a rectangle? Is a rectangle a square? Those are the types of questions we're going to ask. Here we go. All right, so in class today, we started off with a square. What makes a square a square? A square has the properties of a rectangle. It does. Plus 4 equal sides. Therefore, it's a square. Well, let's back up. This is a rectangle. A rectangle has the properties of a parallelogram and 2 sets of equal sides and 4 90-degree angles. Okay? Well, let's back up even further. A parallelogram. Parallelogram. All the sides are congruent? More than that, isn't it? All the sides are congruent. Parallel, 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 parallel. This is more like a diamond, isn't it? You guys remember the name of a diamond, the formal name? Rhombus. Okay, so then that's kind of where we finished class today, was what makes a rhombus, right? Okay, so quadrilateral properties. This is a parallelogram, right? Parallelogram. So we have that side's parallel to that. That side's parallel to that. Okay, so opposite sides and angles are congruent. And the idea of 2 sets of parallel. Okay, now that's how we started the school year back in September. 2 sets of parallel sides. But now I want to spend the rest of the day focusing on the opposite angles. Okay? And in order to do that, it's really helpful if we add the diagonals. Okay? So in your notes, you'll actually see the correct answers and the descriptors. All right? Now let's start adding diagonals. In a parallelogram, if I add the diagonal, okay, opposite sides of the parallelogram are congruent, okay, Opposite sides, boom, 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 boom. Opposite angles are congruent. So this is where I want to focus today, is when we draw the diagonal, that and that, they're equal. That is congruent to that, the opposites. When we actually draw the diagonals, can you see or make a prediction that these are bisected? Bisected? That might be a new word for you, so you might want to take a note there. Bisected, cut in half. All right, cut in half. I also want you to think, because next week and the week after, we start focusing on these triangles we created. Okay? How is that large triangle related to that triangle? Okay? Are they reflections? Are they rotations? Can we say anything there? All right, let's go to the next one. The rhombus. Okay, now before we go to the rhombus, I love the idea of a square because most students can see that corner is congruent to that corner. That corner is congruent to that corner. They're all 90 degrees. Let's go further. That's a 45, that's a 45, that's a 90. Can you see how this triangle is the same as this triangle? The same as this triangle? And the same as this triangle? Squares are really cool. But let's look at the rectangle now. That corner is probably the same as that corner, but it's not the same as that one. Not the same as that one. What triangles are related here? What I'm hoping is that you can get a conjecture that this angle goes to that angle. That this angle goes to this angle. Can you visualize that? Can you see that this triangle is the same as that triangle? This triangle is the same as this triangle? These are the types of things I want to talk about. Okay, so what are the characteristics of the diagonals in a rectangle? Okay, they bisect each other. Okay, so this is congruent to this. I think actually they're all equal, aren't they? All diagonals are equal. We could say that here too. All diagonals are equal. But up in the rhombus, diagonals not equal. Diagonals are not equal. Notice, opposite angles are equal, opposite angles are equal, opposite angles are equal, opposite angles are equal, 360 degrees, total, 360 degrees, total. All right, so we're going to run out of time. Just like in this video, we're already at 10 minutes. Okay, that was what we did in class today. Square, rectangle, 360 degrees total, 360 degrees total. If you have time, let's think about the kite. Wow, totally a different shape, right? But the diagonals form a 90 degree. Diagonals are 90 degrees. They are perpendicular. Okay? Can we say anything about the opposite angles? Are they equal? Are they not equal? Okay? And then we finish with this idea of a trapezoid. All the trapezoids in this class will be isosceles. The number one misspelled word by Monty, isosceles. Okay, don't forget this S right here. Okay, what can we say here? If you have time, focus on that. The answers to this page can be found here. All right. Now, our assignment. I want you to discuss quadrilaterals, okay, 4 sides, okay, 4 sides. That's a quadrilateral, any 4-sided object. But then name them. What's this one called? Okay, parallelogram. The kite. Once you name it, say a couple things about it. Once you name it, say a couple things about it. This one, the trapezoid, not isosceles, not equal on both sides. Okay. Rectangle. What makes a rectangle? Okay. The diamond, the rhombus. Okay, what makes that? There's the isosceles. Now remember, isosceles, 2 equal sides, just 2. Just 2. To make any object isosceles, 2 opposite sides, 2 equal sides, and they're always the opposites. So 1 set of equal sides. All right? And then the last thing to do, if you end up getting there, here's the answer key to the practice. And then this is what we're going to be tested on. Is a square a diamond? Is a kite a trapezoid? Is a parallelogram a rectangle? Okay, keep going. No more than 20 minutes outside of class. Hopefully you start to think about the angles created by the shape. What do we know about the opposite angles? What do we know about the opposite angles? Are they equal? They're not equal. Okay, and then next week, if we draw the diagonal, what happens to those angles? Are they bisected? Are they congruent? What corresponds to what? Is it a rotation? Is it a flip? Is it symmetrical? Those are the questions we're going to ask. Have a great weekend, everybody.